Hi guys, hope all are fine. So today we'll discuss error propagation. What is error propagation? Let's say we have two quantities A and B, and the quantity A has a error of delta A in it, and the quantity B has error of delta B in it, and when we add this quantity we'll get a resultant quantity Z. Now the question is what is the resultant error in the quantity Z? Okay, now the error is propagated from A and B to Z in the process of addition. Now, so studying this transfer of error from set of quantities to some other quantity is called error propagation, and it is not only happening in the process of addition, it is also happening in the process of subtraction, multiplication and division. Okay, let's see in detail how the error is propagated in the process of addition. Okay, now you see I am writing Z with error as Z plus or minus delta Z, and A by A plus or minus delta A, and B by B plus or minus delta B. Okay, now so I'm just rearranging the right hand side by this way, A plus B and plus the addition of these two error. Now the error, this Z and these two can be cancelled. So error in the resultant quantity, that is the addition of two quantities, is plus or minus delta A and delta B. Okay, now the maximum possible error is symbol, the positive signs of this individual error. Okay, delta Z is equal to delta A and delta B. This is the maximum possible error in the resultant quantity when we add two quantity A and B. So got it? Okay, now let's see the error propagation in the process of subtraction of two quantity. So here we are subtracting two quantity A minus B. Okay, we will get a new quantity Z, and in this process how error is propagating, I am writing this individual quantity with error in the following way. And so when we rearrange, we will see we are getting the same relation as we get in the process of addition. Okay, the maximum possible error in the process of subtracting two quantity is same as in the process of addition of two quantity, and that is delta Z is equal to delta A plus delta B. Got it? Okay, next we'll see multiplication. So when we multiply these two quantity A and B, we are getting a new quantity Z, and with error we can represent this quantity by this way. And you see when we multiply these two quantity, we will get four terms AB plus or minus A time delta B, and plus or minus B time delta A, and plus or minus delta A and delta B. Here these are delta A and delta B are errors. Generally they will be smaller in size compared to the original quantity itself, A and B. Okay, so when we multiply two small quantity, we will get much smaller quantity, means much smaller value than delta A and delta B itself. So we can omit this term, last term, and retain only the first three term. And again what I am doing, I am dividing the left hand side by Z and dividing the right hand side by AB. Z is nothing but AB only, so nothing will change. Here you can see when we divide Z by Z, we are getting 1, and here same, we are getting 1 plus or minus delta AB by B and delta A by A. So this is the resultant relative error in the quantity delta Z, that is equal to the addition of relative error in the individual quantity itself. That is, when we multiply A and B, the relative error in the quantity resultant quantity Z is equal to the relative addition of simple arithmetic sum of the relative errors of individual quantity. And same is the case for division. we'll see how the error is propagated in the process of uh, dividing two quantities. Okay, z is equal to a by b, and with error I can represent z and a and b by this way. Here what I am doing, I am taking in the left hand side, I am taking out z, so I will get this term, and the right hand side in the numerator I am taking a commonly out, and the denominator I am taking b commonly out. I will get in this. The a by b is nothing but z, so this is z and this is z can be cancelled, and 1 plus delta z by z is equal to this one. So here I am bringing this denominator quantity to the numerator and raising to the power minus 1, and from binomial expansion I can expand this second term by the following way: 1 minus or plus delta b by, and omit the higher order term, they will be smaller in quantity. So when we multiply this quantity, when we open the bracket, we'll get four such terms. So among these four terms, this delta a and delta b will be lesser in size than the a and b itself. We can omit that, and we'll get three quantities: 1 plus or minus delta a by b, and 1 plus or minus or plus delta b by b. So thus the resultant error in the resultant quantity, re- relative error is equal to relative error in the individual quantity itself. Here you can see this minus or plus is converted to plus or minus, so this won't affect our result, because the error that we are studying will always be either plus or minus. So here minus or plus or minus doesn't matter. That's why we are writing this way. So it is same as the process of multiplication of two quantity. The error is propagating in the division of two quantity is same as the multiplication of two quantity. That's all. Thank you.